Hello everyone, I welcome you all in my channel, The Logical Learning. Before I start today's lecture, I request you to please like it, share it, and also subscribe it. So, today we will learn K-means clustering. So, first we will go through the basic concept of this. Here I have drawn this diagram. As you can see, this is a two-dimensional data. You can assume that two attributes are given, a data with two attributes, say for example x and y. For example, these are the marks of students, marks in say physics, marks in chemistry. So suppose uh, these are the marks of different students in two subjects, physics and suppose say mathematics. So I have shown through graphically. Now we have to find clusters based on these marks on two subjects. So how can we apply K-means algorithm? First, the basic concepts. Remember, it is an unsupervised machine learning algorithm. Unsupervised means no labels are given to you. Only, as I said, marks are given to you, means attributes are given to you. No any classification or labels are assigned to these marks. That's why it is unsupervised machine learning algorithm. Means data, uh, the machine learns from this data itself. It groups data points into K clusters based on similarity. This point is important, based on similarity. So we have to find the similar data points that can form a cluster. And how many clusters are required? This is our choice. We can assign any value to K. For example, here we can assign K equal to 2 or K equal to 3. So it's our choice. Central points of clusters called centroids are randomly selected. What we have to do? Initially, we have to select uh, the centroids or center means as per our choice. We can assume any point as centroids. For example, we can start with say this point as a cluster center and say this is the center of another cluster, and say for example this is the cluster of third center. So this is our choice. We can assume any other point also, this and this also. So this is our choice. Initially we assume any points as cluster centers, or you can say centroids. Now each data point is then assigned to the closest centroid forming a cluster. After selecting these centroids, what we have to do? We have to calculate the distance. Suppose for example of this point, we have to calculate distance of this point from the first centroid, and then distance of this point from second, and then distance of this point from this third one. Now let's take the example of suppose this. I am going to calculate the distance of this point from these three clusters. So this is the distance, this is d1, this is the distance say d2, and this is the distance say d3. So I have three distances, d1, d2 and d3. So in the same way, I have to calculate the distance of each of these data point from first, second and third. Now what we have to do? I have calculated the distance of this point from first centroid, second centroid and third centroid. Now we have three distances d1, d2 and d3. I have to find the minimum of all these distances. It means, look at this word, closest centroid. So minimum distance, say for example this one is minimum d1. So this data point will be assigned cluster number 1. So if d2 is minimum, then the data point will be assigned cluster number 2 and so on. So in this way, each of the data point will be assigned either cluster number 1 or 2 or 3. Now what we have to do? It means after this step, we have three different clusters. Suppose you have initially assumed three clusters. So we have three clusters and every point is assigned to a cluster. Now we have to find the centroids again. Means we have to update the centroids. Initially we have assumed centroids this one and this one. Now we have different points in cluster 1, cluster 2 and cluster 3. So we have to update the centers by calculating average of all these points in a cluster. And this process will be repeated. These steps 4 and 5 will be repeated. Again, as we find the new centroid, then calculate the distances of all these data points from these new centers and form the clusters and find the average of these cluster, that is center points or centroids. So every time centroids will be updated. So this process will be repeated until the centroids stop changing or you form any convergence criteria. This is your choice. How many times you wish to repeat or any other convergence criteria. So for example, you can say until the two consecutive clusters are same. So these may be different criteria you can apply. So we have to repeat this step 4 and 5 until centroids stop changing or some convergence criteria is achieved. So this is the basic concept of K-means algorithm. Now, how can you write this algorithm? First I will tell you distance. Here I have taken Euclidean distance. I am using Euclidean distance. Other distance functions are also there, just like it's Manhattan distance. So we can choose any distance function. Here I am using Euclidean distance. Simply, if the data is one dimensional and points are say x1 and x2, so this distance is defined as modulus x1 minus x2. Modulus means we are not checking the sign. Simply we need to take the distance in positive term. Okay, so that's why it's modulus x1 minus x2. Now if the data is two dimensional, suppose for example data points are t1 and t2, coordinates are x1 y1 x2 y2, so Euclidean distance is defined as under root x1 minus x2 square plus y1 minus y2 whole square, and this formula can be extended to three dimensional, four dimensional and so on. For example, x1 minus x2 whole square plus y1 minus y2 whole square plus y3 minus plus x1 minus x2 whole square, y1 minus y2 whole square, say third point is z1 minus z2 whole square and so on. So we can extend this formula for 3, 4 and n dimension. Now cluster mean, how can you find? It is a simple average. Suppose you have these points in a cluster Ci, Ti1, Ti2, Tin. So suppose after calculating all these distances and assigning clusters, now in suppose cluster Ci you have these points. So how can we update the centroid? Simply we have to calculate the mean of all these points, and mean is this one, mi 1 by n sigma j equal to 1 to n is summation j equal to 1 to n Tij. So Ti is the point in cluster J. So this is the mean of cluster Ci denoted by Mi. N points are there, that's why we have divided with n. J equal to 1 to. Now I will take one example. Before this example, how can we write this algorithm stepwise? Suppose the data points are T1 to Tn, and suppose the desired number of clusters are k. Then how can we write this algorithm? So first step is assign a value to the number of clusters k. Means we have to initialize k. K equal to, you can write 2 or 3 or 4. This is your requirement. However, some algorithms are also there, some processes are also there to find the required number of cluster. Elbow method is there, you can check it. I will discuss later on in some other lecture. So here simply I am describing this k-means algorithm. So after assigning k, assign initial values to centroid, that is m1, m2, mk. So you can assign any values to m1, m2, mk. After doing this, as I told you, calculate distance each of the data point from each of the centroid, and this is denoted by d, ti, mj. Now assign a data point to a cluster if its distance is minimum among all these distances. So these are the steps of K-means algorithm. Simply this algorithm can be written as these points. Now calculate new mean for each of the cluster and repeat step 3, 4, 5 until centroids stop changing or convergence criteria achieved. So these are the steps which you can write as an algorithm for K-means. Now I will take one example. Consider this data point is a one-dimensional data 2, 4, 10, 12, 3, 20, 30, 11, 25. Now assuming two cluster, it means k equal to 2. Apply k-means algorithm to assign each data point a cluster. Now suppose initially I assume the first cluster center is say m equal to 2. So this is cluster number 1, and say for second cluster m2 the mean is say for example 4. So initially I have assigned centroids for first cluster and second cluster. Now what I have to do? I have to calculate the distance of every point from this center mean and from this center mean. So start with say center point 2. Say t1 equal to 2, this point. So distance of 2 from 2 is 0. 2 from 2 is this distance from say c1 from c. Here I write distance of t1 from c1 and c2. So 2 minus 2 0, 2 minus 4 2. So obviously this is minimum. So 2 is assigned to cluster number 1. So cluster number, this point is assigned to cluster number 1. Now next point is say t2 equal to 4. So distance of 4 from 2, this is 2, and distance of 4 from this is 0. So minimum is this one. In the first case minimum this one, I just mark it in this tick mark. So in this case the minimum is 0. So this point is assigned to this cluster number 2. Now similarly look at this 10, t3 equal to 10. So distance of 10 from 2, this is 8, and distance of 10 from 4, here I write its center mean also, this is 2 and this is 4. So distance of 10 from 2, this is 8, this is 6. So minimum is this one. So this point is assigned to data point 10 is assigned to this cluster. Now next point t4, this is 12. So distance from 2 is 10 and distance of 4, this is 8. So minimum is this one. So this point is assigned cluster number 2. T5 equal to 3. So distance of 3 from 2, this is 1 and this is again 1. As I told you, in case of tie, it's your choice whether to assign this cluster number 1 or cluster number 2. So for example, I say I assign it cluster number 1. T6, this point is 20. So this distance is 18 and this distance is 16. So minimum is this one is 16. T6 30. So 30, this is 28, this is 26. Minimum is this one. So this point is assigned 60 here. No, this should not be 16. Actually the point is here 20 and this point is 30. Now T7 11, this distance is 9 and this distance is 7. Minimum is 7. So this point is assigned to second cluster. Now T8 25, So this is 23, this is 21. So minimum is 21. So this point is assigned this cluster. Now after completing this step, so cluster C1, this cluster has only 2 points, 2 comma 3, and cluster 2, this has these points 4 comma 10 comma 12, 12, this is 20, 30, 11, and 25. So these are the clusters after step number one. Once we have calculated the distances of all these points from these two centroids and assigning each point a cluster. So this is the first iteration, you can say. Now what we have to do? Again we have to find the center of these two, just like as center is 2.5 and we need to calculate the center of these points. And how can we calculate? We can calculate 2 plus 3 divided by 2. This is the center m1. This will be updated. Initially we have taken m1 equal to 2, m2 equal to 4, and here m2 equal to 4 plus 10 plus 12 plus 20 plus 30 plus 11 plus 25. And how many points are there? 1 2 3 4 5 6 7. So 7 points are there. So this will be the updated centroid for this center. M1 will be the updated centroid for cluster C1. M2 will be the updated centroid for C2. And again we have to repeat the same process. Now taking this M1 and M2, here we will update this M1 and M2, and again we will calculate the distances of each of the points from these two centroids, and based on the minimum distance we will assign clusters. So this process will be repeated until we have any convergence until we get any convergence criteria. So I have written all these steps here. Look at this. Initially, when after this first iteration, we got each elements 2 and 3 in cluster 1 and 4, 10, 12, 20, 30, 11, 21 cluster 2. So now the updated mean is 2.5. This is the mean of 2 and 3, and for these values the mean is 16. So applying the same process of calculating distance and distances and assigning cluster, we have 3 points in cluster number 1 and these are the points in cluster number 2. So you can do it and you can check it. I just leave it for you as an exercise. So repeat this same process. Next time calculate the average of this. This is 3, average of 3. Now average of all these, this is 18, and again calculate distances and assign cluster to points. So here we have 4 points and here we have these points. Again calculate the average of all these. This is 4.75, this is 19.6, and assign clusters to each of the data points. So here the points will 2 3 4 10 11 12 in cluster number 1 and 20 30 25 in cluster number 2. So repeat the process. The cluster mean is 7, next cluster mean is 25. So now see these two clusters, cluster in iteration 4 and 5, these are same. Here these are same. It means next if we find the average of all these clusters, we will get 7 and 25. So you can choose convergence criteria just like as the previous two clusters are same or centroids are same, then you can stop the process. So finally we have two clusters. One cluster contains all these data points and second cluster contains all these data points 20 30 and 25. So in this way you can perform k-means clustering. This is one dimensional data only. In case of two dimensional data, the only change, we need to apply this formula D and root x1 minus x2 square plus y1 minus y2 whole square. So distance will be calculated based on this formula. So I hope that you got the concept of image clustering, and now